muscle cell. The red paracord at the bottom are the thick filaments called myosin. The tape on the myosin is the ADP and ATP energy. The green slinky is there to show the tropomyosin, the blue button, moving off of the active site, the actin, the pearls in the center, and the pink is the troponin, which calcium binds to. After calcium is released into the sarcoplasm of the cell, of the muscle cell, it migrates over to the thin filaments. After calcium connects itself to troponin, tropomyosin moves off the active site. The high-energy myosin head connects to the exposed active site. Leaving a cross bridge between the thin and thick filaments. This creates a force called the power stroke, which causes the muscle to contract. Now myosin goes back into the low energy state and releases its ATP.
This is the sarcomere. A myofilament is made of thick and thin filaments. They are associated in a particular pattern. The dark green is the thick filament, and the light green is the thin filament. The section with only thin filaments is the I band. The section with only thick filaments is the H zone. The zigzag lines where the thick and thin filaments attach is called the Z disc. Everything between the Z discs make up the sarcomere.
This is a mitochondrion, which contains a sarcoplasmic reticulum, which holds all the calcium that initiates the action potential. If we look at the side, this is the fascicle. It contains the myofibrils, which also contain the myofilaments. The thick filaments are myosin, and the thin filaments are actin, troponin, and tropomyosin. These are T-tubules. The action potential travels down the T-tubule into the neuron. The action potential arrives at the neuron of the skeletal muscle tissue. As the action potential moves down the synaptic cleft, this opens the calcium channels, allowing them into the synaptic vesicle. Calcium allows acetylcholine to fuse to the synaptic cleft. Receptors on the motor end plate pick up on acetylcholine. This depolarizes the motor end plate, allowing the sodium-potassium pump to move potassium out of the cell and sodium into the cell. This increases the positive ions inside of the motor end plate and allows the action potential to move into the sarcolemma